All right, we're going to start by looking at some synthetic divisions for factoring polynomials. Okay, in this first one, I do want you to do long division to divide x cubed plus 4x squared minus 5x minus 14 by x minus 2. So remember long division, put it on the outside, and then you say to yourself, well, what do I multiply x by to get x cubed? Well, I multiply it by x squared. And then you take x squared and you times it by both of those, so you get x squared times x is x cubed. X squared times negative 2 is negative 2x squared. And then remember, you are subtracting that, so you can think about it as changing both those signs. So the x cubes cancel and I'm left with 6x squared. So then I say, well, if I multiply 6x by x, I do get 6x squared. And then 6x times negative 2 is negative 12x. I'm going to bring down that negative 5x, and I am subtracting that. It changes the signs, those cancel, I'm left with 7x minus 14. You multiply 7 times x, and you do get 7x minus 14 as well, so that cancels. You get a remainder of 0. And I do that just so you remember how painful long division can be, and you appreciate synthetic division. The two theorems we have today is the remainder theorem, which says, hey, if you've got a polynomial of degree at least 1, so meaning it's at least linear, and c is a real number, that when p of c is divided by x minus c, so that factor, the remainder is p of c. And what they're saying there is, hey, if you take p of x and you divide it by x minus c, so you take that polynomial and divide it, that the way you could rewrite this is p of x equals the quotient, which they're going to call q of x, times that x minus c plus some remainder. And they're saying, okay, so if you plug in c, right, then you get like q of c, the quotient in terms of c, times c minus c. And right there you should recognize, hey, that's 0. So this whole thing is 0, so you just are left with the remainder. And that's significant. I'm not sure if you've realized this before, but hey, if you just want to find out the remainder, then if you plug in the value, like let's say we plug in this case, when it's x minus 2, if we plug in 2, you would have actually found out that that polynomial gave you 0, right? The remainder was 0 there. So that's like a little shortcut, particularly if you want to know something is a solution. And that's what the factor theorem says, that hey, if you've got this polynomial, a real number c is a 0, of the polynomial if and only if x minus c is a factor of that polynomial. Okay, so this one, let's go ahead, same example, but we're going to work smarter rather than harder. Let's remind ourselves what synthetic division is all about. Remember, x minus 2 really means x equals 2 is the solution, right? I usually put that number over there on the left. There are a couple different ways you can write it. As long as you do the process, it's up to you how you go about it. So now I'm going to go ahead and write the coefficients. So I have 1, 4, negative 5, negative 14. Okay, so now you bring down that first number, you bring down the 1, and you do 1 times 2, the number on the left. So you get, hey, that's 2, and you add these. So 4 plus 2 is 6. Do the same thing. 6 times the 2 over there on the left is 12. You add the column. Negative 5 plus 12 is 7. 7 times 2 is 14, and then you get 0. So notice, hey, my remainder is 0. That does mean it's a factor. If you wanted to think about, as a reminder here, we're saying, hey, what is actually this answer, right? Technically, when we divide that, what do we get? This is originally x cubed, right? X squared, x, and the constant. This answer is 1 degree less. So this is really x squared plus the coefficient of x is 6, and then you've got a constant 7. So this answer would be x squared plus 6x plus 7. Okay, so let's practice again. This time we're taking x cubed plus 5x squared plus 7 and dividing it by x plus 2. Remember, x plus 2, the actual 0 there is negative 2. Okay, so then you start writing your coefficients, like 1, 5. This is where you gotta be careful. Notice there's no x term. We still need a placeholder there, so we're gonna put in the number 0. So you do need to go descending powers, so if it's x squared, x cubed, x squared, x, you can't just skip to the constant. Same thing, bring down the 1. 1 times negative 2 is a negative 2. 5 plus negative 2 is 3. 3 times negative 2 is a negative 6. 0 plus negative 6 is negative 6. Negative 6 times negative 2 is a 12. We get 19 as our remainder. So the 19 is the remainder. And then this whole part, which represents x squared plus 3x minus 6, is the quotient. And sometimes they will also write it as like x squared plus the 3x minus the 6 plus your remainder of 19 over what we divided by, so x plus 2. Okay. Nice job. Let's go ahead and take a look at these next ones. On these next ones, when we say, hey, we're trying to find a 0, let's go ahead and just plug in like negative 2, for example, into this polynomial. If I do that, I'm going to replace all my x's with that value, so negative 2 cubed minus 5 times negative 2 plus 3. So when you do negative 2 cubed, you get 8. 8 times 2 is 16. Negative 5 times negative 2 is 10 plus 3. We do end up with a, oh, that is negative. That's my bad. So then we get negative 16 plus 10 plus 3. We do get a negative 3. Okay. So what that means is, hey, if I was to divide that polynomial by x plus 2, right, then I would get a remainder of negative 3. I don't even need to do synthetic division if all I'm asking for is the remainder. Same thing here. If you plug in 5, so 2 times 5 cubed minus 5 times 5 plus 3. 5 cubed, I believe, is 125 times 2 is 250 minus 25 plus 3 does give us 228. Okay. So given that x equals 1 is a 0, find the remaining ones. Okay, so let's plug in that 1. We've got our coefficients of 2. Oh, but I forgot. You gotta have a 0 in there. Negative 5, 3. Bring down the 2. And then we do 2 times 1 is 2. Add it, we get 2 again. 2 times 1 again is 2. We add it, we get negative 3. Negative 3 times 1 is negative 3. Hey, we did get a 0. That's a good sign. But now we're left with this polynomial, right? We're left with 2x squared plus 2x minus 3. Someone asked me, like, hey, why are we using synthetic division to begin with? In general, if we have something larger than degree 2, so a cubic, a quartic, etc., you're going to use synthetic division to get the polynomial down to a quadratic, which then we know how to solve without too much effort, right? Once you see this quadratic, you may start to think, okay, well, I'll just factor it. So you're like, what multiplies to negative 6 adds to 2. Unfortunately, this one is not factorable. So what we're going to do from there then is we're going to go ahead and use a quadratic formula. So x equals negative b is a negative 2 plus or minus the square root of b squared, so 2 squared minus 4 times a times c. So 4 times 2 times negative 3. All divided by 2 times a is 2 times 2. So we get negative 2 plus or minus. When you evaluate what's under the square root, we get square root of 28 all over 4. Well, you can leave the answer like that. Since we are in college algebra, it's good just to refine your skills. So like, how do you simplify the square root of 28? We got 7 and 4. 4 breaks down to 2 and 2. So you could rewrite this as negative 2 plus or minus 2 square roots of 7 over 4. And then that does simplify, like 2 over 4 is the same as a half. So it'd be negative 1 plus or minus square root of 7 over 4. So as you think about your zeros, well, we already knew 1 was a 0. We've got negative 1 plus the square root of 7 over 4. And you've got negative 1 minus the square root of 7 over 4. Okay. A couple more here. So we got another polynomial, and we have here that c equals a half is a 0. But this time it has a multiplicity 2. So remember that means that it happens twice. Find the rest of the real zeros and factor the polynomial. So if I'm going to plug in a half, I've got my coefficients of 4, negative 28, 61, negative 42, 9. I think at this stage you got it. I'm going to go through the process but not talk it out loud this time. And we've got 0. That's a good sign, right? That means it is a 0. That's what we expected. This, I'm going to do a half again because it has multiplicity 2, meaning, hey, it happens twice. I usually kind of cheat and just use the same one and do it twice. Looking good, we got a 0 again. The quadratic we're left with then is 4x squared minus 24x plus 36 equals 0. So there's a couple of different ways to think about this, right? I could say, hey, that polynomial, right, times x minus 1/2 squared is equal to my original. A lot of times I would think like, hey, let me just handle this one. Like, I'm going to factor out a 4, and I get x squared minus 6x plus 9. I'm just going to solve this first, and then I'll worry about the factored form because we want to find the rest of them and factor it. Either way is fine, kind of whatever process you want. So I'm going to divide both sides by 4 now. The 4 should then cancel. I get x squared minus 6x plus 9 equals 0, which is x minus 3 times x minus 3, or x minus 3 squared, equals 0. So we do get x equals 3. Once again, it is a multiplicity of 2, though, right? Your other one is x equals a half, multiplicity 2. So those are our zeros. We've got 4 zeros, makes sense because we got a 4th degree polynomial. When we think about writing it in factored form, technically I already have that x minus 3 squared. And if you think about x being a half, right? X equals a half. So if you set it equal to 0, x minus a half equals 0. And then usually you don't see fractions as a factor, so you think about getting rid of that denominator. We're going to multiply everything by 2 on both sides. So you get 2x minus 1 equals 0 is going to be that factor. And since it's multiplicity 2, we're going to have squared. Okay, someone asked me kind of in class and stuff, they said, hey, if that's the case, did I need to take that 4 into consideration? Technically here, because we wrote it out as like that 2x minus 1, we'll get that coefficient of 4 out front, so we're all set. If you wrote it as x minus a half, then yes, you would need to still keep that 4 out front like we did when we factored over there in the middle. Okay, a few more. We're going to create some equations. So you may leave the polynomial in factor form. That is a key thing. Don't make your life harder than it needs to. So first thing we say, hey, there's zeros of the polynomial. Our c is plus or minus 2. C is plus or minus 1. And then let's come back to the leading term. So if you've got c is equal to 2, that means x minus 2 is a factor, right? If it's negative 2, x plus 2. Remember, it's like the opposite. So for the plus and minus 1, you'd have x minus 1. You'd have x plus 1 are the different factors. And this is some polynomial p of x. Just like in the last lesson, we usually have to solve for some a out front. But here, if it tells you your leading term is 117, x to the 4th, well, we know we get the 4th degree from the 4 different zeros, and they're just saying, hey, the number out front is 117. And you're done. Okay, next one's similar but a little trickier. This one has a root degree 3 polynomial, a root multiplicity of 2 at x equals 5. So that means x minus 5, and since it is degree 2, sorry, root multiplicity 2, it's going to be squared. and a multiplicity of 1 at x equals negative 4, so x plus 4. And you could put to the first power, but you don't have to. And this is some polynomial. I'll just say, hey, p of x. The one thing, though, we need to find out is that a. And they tell you one other thing. The y-intercept is negative 20, which means, hey, your y value is negative 20 when x is 0, right? So with that, you should then be able to find a. And that's the biggest thing people forget, is just to go back and solve for a. So you'd have negative 20 equals a times 100. So a equals negative 20 over 100, which is the same as negative 1/5. So our polynomial then is p of x equals negative 1/5, x minus 5 squared, x plus 4 squared, x plus 4. Oops, sorry about that. I crossed it out. Okay, last but not least, we've got a polynomial degree 4. So it's got root multiplicity 2 at x equals 4, so that means x minus 4 is squared. Multiplicity of 1 at x equals 0. X equals 0 you could say is x minus 0, but you don't really even need to subtract 0. It's really just x. So a lot of times for something like that, we would just write x out front as well. And then x equals negative 1 as x plus 1. Just like in our other examples, we're going to call it some p of x, and we do need to find what a is out front. This time it's a little bit different, but same idea. They tell you that the point 5, 15 is on the graph. So your y value is 15 when your x value is 5. So same exact idea, just a different point than what we've had before. So we get 15 equals a times, once you do all that, you get 30. A equals 15 over 30, which is the same as 1/2. Okay, so my final polynomial is p of x equals 1/2 x, oops, I forgot to do the x up front, and then x minus 4 squared, x plus 1. And we're all set.